Goedemiddag, welkom terug weer bij de LabAutomation online themadagen. We hebben vandaag al diverse mooie presentaties gezien over innovatie 4.0, de digitale revolutie, robotisering. Allemaal interessante onderwerpen. En ik switch nu even naar Engels, because our next speaker is going to do the presentation in English. Next up is Christian Sampedro from Festo, and he will be talking about liquid handling. His colleague, Benno Brinkers, will be present in the chat answering all your questions. So please leave any questions that you have in the chat. We will be sharing this presentation afterwards with you if you would like to look at it again. So maybe that's good to know. And for now, I would like to give the word to Christian.
Yeah, dank u wel. Yeah, hello also from my side. Yeah, like you already know, my name is Christian Sampedro. I'm the product manager in the area of liquid handling, specific for media separated valves at Festo. And today I would like to present you the pressure-driven dispensing approach in the liquid handling world. So it's not only dispensing, we are also talking about aspirating and pipetting, but you will see this in the next 30 minutes. Like we heard before, there's also Benno Brinkers in the chat. He's able to answer all your questions, even in Dutch, because he is from the Netherlands. I'm from Germany. I'm now sitting in Stuttgart at my home, and therefore I can understand Dutch a little bit when I hear and figure it out. But yeah, Benno is the expert in the language here. So what we want to do in the next 30 minutes, have a look to the agenda. So first of all, we have a look what is liquid handling in general, and not what is liquid handling, where we can find this. So we are talking about some applications and having a look to the basics, this wording, dispensing, aspirating, pipetting, only a brief look that we are talking about the same. When I'm using these words, that you understand what I'm meaning with that. After this, we are coming to the customer needs. To make it short, volume and precision are always big topics, but they are also something around. Then we are going to the approaches of liquid handling, having a brief look which approaches exist, and then we are going to the main part of this session, to the pressure over liquid approach, and talk about how this looks like, the theory behind, and also which components you need to build up such systems. After this, also we will have a closer look to which challenges may occur when you are using this approach, and also some proactive measures against it. So I think there are only small screws to turn, and then you won't have any problem anymore. And last but not least, we will wrap up everything. Okay, let's start. So where you can find this application. So I picked two applications to start with here with the ELISA test for COVID-19. We have seen this in the last months very often in the television. I do not want to explain what is ELISA here. I only want to show you something. So when we're having a look to the standard process of ELISA, you will see you often have some liquids you have to transport from A to B with different approaches. Sometimes you are coming from a tube. For example, there's a patient sample inside, so you only have few milliliters, microliters of this. Then sometimes you have a big reservoirs of some washing liquids, for example. So these are two different things, they are to be handled in a different way. You see also we have the topic cross-contamination, and we are talking about disposable tips here maybe, but sometimes also with we can do something with steel needles and much easier. To make it short, we're talking about liquids coming from A to B, a certain amount of liquid with a defined precision. So you want to have every time the same value when you're doing this more tests in a row. Another example with the PCR test, I think that's going in the same direction, but I picked this because I think everybody's aware about this for of you. I think everybody from us had this little swab in the nose, and this is going to a little tube, and from this tube you want to pipette into microtiter plates, And then when it's going to testing in the sample preparation, you add also some enzymes for the PCR test with a defined volume also in the microtator plates, and then put this to a PCS test device. So also here for sample preparation, you want to move some liquids from A to B. And now we're having a look how to do this. Or before we started this, I said before, we are concretizate the wording. When I'm talking about dispensing, I often mean only we are coming from a big reservoir, and this we put into our target vessels. When we are talking about aspiration, I mean we are sucking off the target vessel, and we put this to a waste reservoir or to the liquid reservoir itself again. And when I'm talking about pipetting, I mean, for example, here we have on the right these little tiny tube and coming with like a pipette and only with small volumes and put this directly to the target. What's the difference? You see dispensing, aspirating, there is a bigger amount there. The border of this approach is how much liquid is possible in the reservoir. Here in the tubes, we are only talking about really few microliters or milliliters. Okay. Customer needs, I already mentioned, there are a lot of different customer needs. I think you can cluster this to more or less 5 main needs. We're always talking about a certain volume. You want to transport a certain volume from A to B, e.g. 1 microliter. And here there are some other things to look at. There are a lot of dependencies, example, the temperature, the viscosity, and a lot of other things you have to look at. Then on the other hand, I said it before, we are talking about precision. You want to transport every time the same amount of liquid. We are talking about the CV value, but there are a lot of different CV values we will see later on. So in accuracy, and also we have some other KPIs, and I see it in the practice. They are mixed up a little bit sometimes. So when we are talking about minimum value and the deviation from min and max together with CV, they're a little bit mixed up. And for sure, we are talking about cross-contamination, suitable price. Always we are talking about the price as well, and speed and capacity for approaches, for liquid handling approaches. So finally, we can say, I think the most important thing is we want to transport liquid from A to B with a certain amount, we want to transport a liquid from A to B with a defined CV. So in a range that we are doing every time the same. And now the question raised up, how we can do this? So how we can transport this liquid from A to B in a laboratory automation device. So for sure, we can do it manually with a pipette in our hand. Like you see it, I think in Germany, it's in the news every day when you're looking to the television with how people do this by hand, but we want to talk about automation. And for sure, there are a lot of different approaches in the market. So I picked up, for my opinion, the 3 most common. So we have the pressure-driven approach. I want to explain it today. We have the sewage pump approach, peristaltic pump approach, but also there are a lot of other approaches as well. And I do not want to go too much in detail here because we do not have too much time. We want to concentrate on pressure-driven dispensing or aspirating or pipetting approach. So also we call it the pressure over liquid. And yet, to give you the 2 or 3 highlights of this, what are the big benefits here? So when you want to have a high throughput and really nice CV values, this approach could be the key approach for you. But yeah, let's go more in detail and have a look how it looks like. How look a pressure-driven dispensing approach or the pressure over liquid approach? How the principle works. So the principle is very easy. So you have 2, 3 main components. You have the liquid reservoir where your liquid is in. You have a dosing head in between a tube, and you put some pressure into the liquid reservoir. Then the liquid is going through the tubing or through the pipe to a valve. It's a 2-2 normally closed valve. We are using, or we also recommend to use a meter separated valve. And by opening and closing this liquid valve, this tiny liquid valve, you dispense. So these two values, the defined pressure and the opening time of the valve, defines how much liquid you dispense. The same you can do with vacuum. When you have vacuum here, you can aspirate. And the same principle we will see later on, you can also use for pipetting solutions. Also by pipetting, the difference is that the liquid is not going through the whole system. When I'm talking about pipetting, I'm only talking this liquid is staying in the tip in front of. Dispensing, aspirating, all parts here are going to be wetted. So we see here pressure control and the valve. These are the two main components to control the liquids. There are some other things to look at, for example, the length of the tube. So there are a lot of things that could influence our system, but with these two values, with these variables, we can define the amount of liquid we want to dispense. And this is how it looks like with a little picture. You can imagine it. We have this bottle with the fittings. We put some pressure inside, and then we are going through a tubing to a manifold. On the manifold, we can find a meter separated valve, and then with switching on off, with going through channels, through this liquid fitting, through a needle, and then we will dispense. So very simple. Okay, so now we understand how the principle works with pressure and opening times of the valves. So which components do we need and which things we have to look at? So like I said, we need a pressure vacuum generator to put some pressure here into the bottle. We are talking not about big pressures. Normally we are using between 200 and 500 millibars. So it's not dangerous that the bottle explodes. And here, like I said, we have a dispense head. On this dispense head, the main component is this meter separated valve. And for sure, we have a control unit, like a PLC or PC, where we're giving the commands to these components. So you see there's another component, a valve control module, why it's here, and also this line. So you can control the valves, the dispense head with your PLC, but you be aware of that the PLC is fast enough. Imagine when you want to dispense few amount of microliters, the opening time of the valves is very short. So we are talking about few milliseconds, 4 to 6 milliseconds, for example. And when the time resolution of your PLC is, for example, 10 milliseconds, then for sure you will have different opening times and therefore different dispensed values, and then also you will get pretty bad CVs. Therefore, please be aware that the system or the controlling unit you are using, it's fast enough. And because there are some standard PLCs on the market, and we should say you have to switch the whole controlling unit in your system, there are also some valve control modules. You can also put it in between, and this is doing this. So you can control the valve control module, and this is give the commands to the valves in the right speeds. So we recommend in general time resolution of 0.2 milliseconds, that you have really these tiny intervals and really a precise control of the valves. Okay, what else? So for the dispense heads, we can talk about different solutions in the market. So with the same approach, you can address different things. You can say you have one liquid is coming to one input of the dispense head and go out of one output. You can have 8 different kinds of liquids and 8 different outputs. For sure, you can also summarize these liquids before up and then share this to 8 different outputs. But for this solution, there are also some solutions that you only have one input, and with only one valve, by switching on off the valves, you can divide the liquid into 8 channels, and then you have 8 times the same liquid you dispensed. And this you can everything you can put together and build up 96 channel dispense heads or whatever you want. Another thing to mention is, you have also different opportunities for the pressure and vacuum, how to generate it. For example, when you have a central pressure air supply in the lab, you can use this with very simple components. And if you don't have this, you need like a little tiny box where you can have a decentral pressure and vacuum supply. So like this picture here in the middle, this pressure vacuum generator, this could be a solution. There are some on the market. It's like a little box, like a box for shoes, a little bit more smaller. But here you can generate vacuum and pressure for these liquid handling applications. They are specially made for that. But also when you have pressure supply in the lab, you can also use this one. Okay, now we talked about how the system works and how to dispense. Yeah, okay, now we know with the pressure and opening time, we can define the target values, the volume you want to dispense. And now the question is, which volumes we can dispense with such a system, and what is the CV, the coefficient of variation, the precision of the system. And here I'm showing you it's only a single test of one example dispense head. You can see we are talking about the dispense volumes between 0 and 100 microliter, which you can dispense in an impulse time from 0 to 100 milliseconds with CVs below 2%. You see there's also a linearity, so it depends how long the impulse time is, so how long the valve is open, and you see there is a very linear curve where these values are. So you can calculate very easily which time and pressure you want to set up to get the volume you want to dispense. Okay, so coming back, I need to drink a little bit because I have a dry tongue. Okay, the next thing we want to look at, I already told you we have different options for different kind of dispense heads. And now the question is, okay, when we not only having one channel, we have 8 different channels with 8 different valves, then it could be very hard to get the right CV value when you're having a look to the whole plate. So when we're talking about the microtator plate, you're filling this up with 8 different channels, 8 different valves. It could be possible because there are a lot of influences that each row has a little bit another value. And you want to control this, that each channel is doing the same. Maybe you have to influence the opening time of each valve a little bit, that not everything has the same opening time, because the length of the tubing and all the things could be aware of. And there we can reach also really nice values. I mean, we made here some tests with like a dispense head with 8 channels, 8 different valves, and we had a CV about 4%. I mean a tip-to-tip CV, that means we have a look to the whole channel. So what is the difference again? Interrun, it's only looking to one channel, and tip-to-tip means, so what is the whole microtator plate looking like? And by optimizing this for each channel, we were able to reduce the CV to only 1%. And we did this with these kind of valve control module, because there also you can define like hit and hold actuation, so you can reduce the current and you can set up very easily these opening times for each valve very easily. So you see in the system, you have like single components, but you can enlarge the system and put more into this to still improve the system. What else? This is what I said now. You can enlarge the system, you can put more features, more functionalities. Here, a little example that when you have like two liquids, for example, a washing solution, a cleaning agent, you can switch this with also meter separated valves. I have seen a lot of customers doing like that. Put meter separated valves on the manifolds and switch some liquids before they are going to the dispense head, and then also you can use with pressure and vacuum. One liquid is going into the blade, another one is going out of the blade. Okay, this was dispensing and pipetting. Now let's coming to dispensing and aspirating. Sorry, now the question is, what will be changed when we are talking pipetting? And the system I can show you very briefly is pretty much the same. The only difference is we do not need any liquid reservoir anymore, and there's only going a pressure line to the valve. So the valve here is only running with pressure and vacuum because the liquid stays in the tip. And there are also two different approaches. We have like an open loop system that we have to control it, like I explained to you before, but also there are some closed loop approaches that you only give the command to the pipette, and this pipette is very smart and have intelligence inside, and everything else is doing in the pipette. And for sure here, which components do you need for a pipette? We are talking about also disposable tips you need here. Yeah, and last but not least, for this pipetting approach, you can also enlarge this approach. This, the first slide, where only the little setup, which components you need for the general, for the basic setup of this approach, but you can add a lot of other things. You can add some sensors and hardware stuff to realize some features and functionalities. For example, you want to have liquid level detection. So you want to know when the pipette is hitting the liquid, that you know, okay, here's a liquid, I have to dive into the liquid from this point and then suck the right amount of liquid. You can add process monitoring stuff. All these things are software based with some inputs from the sensors, but you also can add some other features like tip ejection that you can release also the tip when it's used and you want to put this in a bin. Yeah. And finally, you put everything together with some kinematics, and then you have a complete liquid handling system. And this is also very important. Liquid handling is not standing alone. You always need sample preparation, or you need the liquid handling and sample preparation together to build up a complete liquid handling system. And also when you have different process steps in your application, then you also need different kind of components. Here in this picture, you see there are coming some tubes. Okay, you have to open the tubes, you have to transport the tube, you have to go with a pipette through this, you have to go down to pipette the volume, you have to go to another place and divide this volume to a microtiter plate. So you see there are a lot of movements and some kinematics, some mechatronic device also necessary to put everything together. And I will start a video also that you can see some movement here, how it looks like in action. that a lot of things should work together. It's not only liquid handling, it's a lot of other stuff. So for me, the video is running. Maybe you have a little time gap, but yeah, the next few seconds it should start when it's not running. So in this video, you see also some movements, some dispense heads, dispense some liquids. You will see some cappers, some decappers, and also you will see pipetting solutions, and you see everything is running together. Okay. So before I coming to the end, I want to give you some notes about some challenges and how we can solve this. So when we are talking about this pressure-driven dispensing approach, and probably also with other approaches, there are some circumstances that we do not have the right results. And more or less, we are talking about every time the same things. We have some particles in the system. We have some leakage because there are some particles in the system. We do not have a closer look to the environmental conditions. So here you will get the slides later on. I see we only have 2 minutes left. So here are some courses and some recommended actions to solve problems when they occur. And for me, the advice to you, do it proactively, flush your system, have a look that all the environmental conditions are constant, clean the products before installing, and then you won't have problems anymore. And for sure, use fast enough controlling units, because this is often a big issue in this approach. Okay, coming to the end, what did you learn or have you seen today? So I think we talked about, we know in our liquid handling applications, we're talking about a certain amount of liquid is going with a defined precision from A to B. We have seen different approaches and some advantages and disadvantages. We had a closer look to the pressure-driven solutions and that they are good for high throughput and good precision, because we can do this pretty fast. We had a look to the setup of a pressure-driven solution. We saw the components which are necessary, and we learned that additional features can be added to the system as well. And at the end, so with the video and the picture we saw, liquid handling is not only standing alone, it's a part of a complete sample handling system. When you are going to the lab, you see everything is running together. So I'm at the end. Thank you for your attention. And now we are open for some questions.
Well, Christian, thanks for your presentation. We've got some questions. One is from Peter, and he's asking, what is the maximum viscosity that can be dosed with the pressure of a liquid system? Can you tell something about it?
Yeah, that's a pretty nice question. And we do not know what is the maximum. so far. We are doing some tests currently in our headquarters, but for sure I can say with until 20 millipascal it is suitable, but probably even more. So we are just testing it with different viscosities. So we tested everything with water and suitable lab liquids, but here please get in contact with Benno in the Netherlands, and when we are having some values, we will inform you.
Okay. So, yeah, as said, if you want to have more detailed information, then we can do some tests maybe in our headquarters for that. There is another question came in, that is, how can we prevent the vacuum line dispense heads from being clotted? And that's something you already told about flushing and cleaning. Mm-hmm. Is there something else you can add to that? How we can keep it open and clean?
Yes, this I think is the best answer.
Okay.
There is also another question with the cell cultures. This is going, or Benno, I think you have to switch off your microphone shortly. I have an echo. With the cell cultures, it's the same thing. We also want to test this with HeLa cells in our lab, but we didn't do this so far. But we are planned to do this as well, to give you there an answer. And the maximum volume of dispensable, it depends on the liquid reservoir you have. So we had some customers in a totally different industry segment. They're having big reservoirs like thousands of liters, and they are also doing this same approach. There was also a question from Dimitri, which kind brands of disposable tips can be used with everything you want. It depends on the supplier, but yeah, for our system, we are used to the T-can tips, or also Festo is offering some tips now. So you also can use these ones. How easy is the programming of methods? I do not know which methods you mean. Maybe you need some process steps that you say, okay, dispense 1 microliter, then 5 microliter, then 10 microliters. Yeah, how easy is when you're a good when you're a good IT specialist? I think it's no problem. So our trade show department is doing this very easily to build up such machines, and they are not really liquid handling experts. So Benny, do you have some other things?
I think it's depending on the programmers, and yeah. I'm not sure. There are different kinds of controlling systems. You can use PLCs or microsystems. So that's not up to us. We have only the hardware to control it, and we have some controllers which can do, but also partly. And so if you need some advice or you want to discuss with it, then we are open for that. I think we are through all the questions. I think, Peter, I will come back to you on your question about the viscosity and maybe get some more detailed information from our headquarters. Okay, we are to the end of the presentation and have had all the questions. I want to point out that we as Festo have also other webinars organized. You can find them on our homepage, www.festo.nl. There you can subscribe to other webinars, also from our headquarters in Germany, but also from England, where we are going to talk about IVD point of care uses. And these are also very interesting to find and to follow. Thanks for your time.
Thank you.
Okay. Thank you very much, Christian, for your presentation, and Benno for monitoring the chat. Thank you, of course, also for all people viewing this webinar. I would just like to remind you that we do have some more presentations today and this Thursday. So I will be sharing a link with you via which you can register for the next presentation, which will be about pipettes. And you can register via the link that I just shared. As I mentioned before, we will share the slides of this presentation next Thursday, so you can go through everything once more. Yeah, Christian, once again, thank you. And also Benno, of course. And yeah, looking forward to seeing you in another session. Thank you very much.
Thank you. Bye.
Bye-bye.